Okay, perfect. We're recording. So again, I'm going to lecture, try to manage the chat, but if y'all will help me with the chat, I'd greatly appreciate it. Just like class, if you will be on mute for the time being, but if you have a question, please just unmute yourself and ask any questions that you have. Just interrupt me. I'm not offended. Uh, I might get interrupted by my husband if things are crazy outside of this room. It's very possible. So I just pardon any interruption on that, but we'll get started. So, like I said, today we are going over just miscellaneous equations. If you have questions, please ask. We're going over polynomial equations, factoring, rational exponents, equations that reduce to a quadratic, maybe that one, I'm not sure. We might skip. Equations with one square root, and then absolute value equations. So a lot. So like I said, if you have questions, just ask. All right. So now, of course, my printer is also not working at home. So I had to copy the examples to just a scratch piece of paper. So let me move over and share screen to my dot cam. Sorry, y'all. Perfect. Okay, wonderful. Y'all let me know if you can't see or, any of the other stuff. So starting off with just solving polynomials, we have so example one, solve 5x to the fourth equals 80x squared. Well, all polynomials, we love setting them equal to 0. So generally speaking, I like my polynomials to be, I like the highest degree, so in this case, the fourth, the highest exponent, to be the positive term. So I'm going to subtract that 80x squared over, so that I have 5x to the fourth minus 80x squared equaling 0. Next, we want to keep solving. In this case, since we only have 2 terms, it's kind of nice. We just want to factor out everything we possibly can from both terms, our greatest common factor, essentially. So what do 5x to the fourth and 80x squared have in common?
X squared.
Perfect. X squared. Anything else?
A 5, correct?
Yes. Awesome. So that leaves x squared minus, and then 5 can go into 80 how many times? Let's see.
16?
5 can.
Is that in my head?
Let's see. Yeah. I'll believe you. Yeah, that sounds right. Let's just see here. 80 divided by 5. Beautiful. Yeah, awesome. Okay. So we now have 5x squared times x squared minus 16. So now we mentioned it before when we talked about complex conjugates. If y'all remember, this is the difference of squares. So this is x squared minus 16. So we have 5x squared. And then the difference of squares, remember, they're conjugate. It's plus and minus the square root of the first term and the square root of the last term. So this is just 5x squared times x minus 4 times x plus 4. So the zero product principle says that any 2 terms, any 3 terms, if they're multiplied together equals 0, well, that means each term can potentially equal 0. So we take each term, set them equal to 0, and solve. So what 3 numbers does x equal to? Y'all help me out.
Positive 4, negative 4,
Mm-hmm.
and 5x squared, right?
Yeah, so if 5x squared equals 0, if we divide by 5, what's 0 divided by 5?
Oh, 0.
0, yeah. And then what's the square root of 0?
0.
Yeah, also 0. So our 3 answers are 0, negative 4, and 4.
Does it matter at the top what, like, if the negative and the positive goes first, like in any other equation? I know in this one it doesn't.
Shouldn't.
Okay.
Nope. You mean in terms of like how we list the answers?
No, like on where it says 5x squared and then you open parentheses x minus 4 open the next parentheses, x plus 4 equals 0?
Oh, no, it doesn't matter. So if you have x plus 4, x minus 4, that's totally fine.
Okay.
Yeah. Was there another question?
Yes. What's the principle called again that lets us set each of these individually to 0?
It's called the zero product principle. So zero product. So if product means multiplication. So if the product is equal to 0, so if A times B is equal to 0, then either A and or B is equal to 0. So this principle says if I have factors or terms that are multiplied that equal 0, we set all of the factors equal to 0 and solve, and that's how we get the solution.
Okay. So we don't FOIL either?
Right, we don't have to FOIL. So FOIL is equal to distributing. So that would be like x plus 3 times x minus 2 and distributing. We are factoring.
Okay.
Which is undoing. Good. Undoing FOIL, if you would, or distributing. Perfect. Does that make sense to everyone?
Equation called?
Say again.
What is this type of equation called?
Higher degree polynomials.
Okay, thank you.
You're welcome. Okay, so next, are we ready for example 2? So this is also a higher degree polynomial. Higher degree meaning like larger than 2, because then it would fall under just quadratics, right? And we had a whole lesson on quadratics that I made the video for. So here, let me get a different color. This is a cubic, so it has 4 terms. If I have 4 terms, my go-to is what we call factor by grouping. Factor by grouping. Remember the mathematicians back in the day, tired from inventing math, so they called it by what it did, say, or is. In this case, you factor by grouping. So we're going to group the first 2 together and the back 2 together. And we're going to factor those semi-separately. So essentially ignore the back 2 terms and just look at the front 2 and ask yourself, okay, what do these 2 terms have in common? So what is their greatest common factor? Y'all help me. So x cubed and x squared, what can we factor out?
X squared.
X squared.
Beautiful. So then our quote leftovers is x plus 1. All right, now the name of the game is that when we look at the back 2, we need x plus 1 specifically to be our leftovers, okay? So the question is now almost reverse engineering. So if I have negative 9x minus 9, what do we factor out so that I am forced with x plus 1 left over? Y'all help.
Negative 9.
Amazing. Amazing. Yes, y'all. Okay, now, again, so we have two factors, x squared times x plus 1 and minus 9 times x plus 1. So what's cool is that we now have a common factor between the two groups. The x plus 1 is the common factor, and it is now our greatest common factor, and it gets factored out. So it's x plus 1, and then we have our leftovers times x squared minus 9 equal to 0. Isn't that fun? So what is x squared minus 9? A difference of squares. Yeah, difference of squares. So it factors also x plus 1, x, if you want to do x plus 3, x minus 3, that's totally fine. Ta-da! All right, so zero product principle says we take each term set it equal to 0 and solve. So x plus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0. So what 3 numbers does x equal?
Is it negative 1, negative 3, and positive 3?
Positive 3.
Yay, 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 yay. Perfect, y'all. So I want you to make note because we're going to talk about this later on in the semester. This right here, the highest exponent is what we call the degree. Hot tip. So the highest exponent is what we call the degree. So notice the degree is 3, and how many answers or solutions did we get? 3,
Do we need
right?
to like write out each of those 3 equations, or can we just do plus or minus 3?
Oh, you can do plus or minus 3. That's fine.
Okay, cool.
So we have degree 3 and we have 3 solutions. Notice here that we had degree 4 and we have 3 solutions, but technically this x was an x squared. So it's almost like the zeros getting counted twice. So whatever our degree is, and remember that's the highest exponent, whatever the degree is, that's the most solutions we can have. So here we have degree 4. So if we got 4 solutions, that would be cool. That's fine. Having 3 is excellent as well, because the 0, because it was attached with an x squared, essentially pseudo is getting counted twice, right? So that's how we have 1, 2, 3, 4 solutions. Just food for thought. We're going to talk about this more when we get into polynomials, but just kind of leaving you a little knowledge breadcrumb. Let's see. Where did I get x squared from in the x plus 1? This x squared right here. Oh, this one is just the factor of the first 2 terms. Oh, hang on, let's see. So when we're first starting, we want to group, factor by grouping. So we want to group the first 2, then the back 2. So this first grouping is just recognizing that both x cubed and x squared have an x squared. So we factored out this x squared. So what is left over when we factor out this x squared is just x plus 1. Does that make sense? Perfect. Yeah, I'm in the chat. Sorry.
How did you
Okay.
get x plus 1 from the negative 9x minus 9? How did you get that?
Here,
Yeah, how did you get
yeah.
that the leftover?
Good. So here, it's technically whenever we have 9 times 1, essentially, if we want to say it that way. And it's also, there's a place right here, so to speak. So the 1 is a placeholder to say that this constant place exists. So when we factor out the 9, well, 9 divided by 9 is 1. So that's what happens. So if I have 9x divided by 9, well, that's 1x. We don't need to write the 1 though. 9 divided by 9 is 1, so we will write it because now the place disappears, if you would, okay? So it is x plus 1, because when we take out the 9, essentially you're dividing this entire term by 9. Does that make sense?
Yes, thank you.
Good. Yay! Okay, so that essentially is that's covering majority of the bases for the higher degree polynomials, the first bullet point. Generally speaking, you're just going to be factoring or specifically factor by grouping. Any questions on 1 and 2 before we move on to rational exponents?
I have a question. How did you get x squared minus 9?
X squared minus 9. Oh, so here when we factor out the x plus 1, the x squared minus 9, those are our new leftovers. So those become the term that's left over when we factor out the x plus 1. Yes, no, maybe?
That makes sense.
Okay, great. All right, so let's move on to the next one. Let me hop over into the notes. Sorry, y'all. Bear with me. Okay, so we are now into the solving equations with rational exponents. So recall the exponent rules for rational exponents. A to the 1 over n is equal to the nth root of a, right? So fractional exponents actually introduce rationals, okay? Fractional exponents introduce radicals, sorry. So if I have a to the m divided by n, well, this is the nth root of a raised to the m power, or the nth root of a to the m. So why we care is that if I have example a, x to the 5/4, well, this is now can be thought of as the fourth root of x to the fifth power. So how we go about solving is we isolate the expression being taken to a rational exponent on one side of the equation, raise both sides of the power that the reciprocal is the current value or current power, and then simplify and solve. So let's see. Pop back over. Perfect. So here, what we mean we want to raise to the exponent is because 5/4 times its reciprocal, 4/5. Well, that is then 20/20. And what do we know about anything over itself?
Like that side of your knee is so
It's 1.
Yeah.
Equals
Perfect.
1.
Yay. Yeah. Awesome. Thank y'all. It's 1. So basically, we're just doing that to kind of go straight in for the kill. Okay. So we raise both sides to the 4/5 because, again, whatever we do to one side, we have to do to the other. So let me just rewrite it so I have room. So x to the 5/4 equals 32. Now we're going to raise both sides to the 4/5. The 4/5. So over here on the left, we already established, hopefully, that x to the 5/4 raised to the 4/5 is just plain old x to the first power, right? Okay. And then, sorry, muting people. So now we have 32 to the 4/5 power. You can, let me grab my calculator, which is not in here. That's okay. I'll use, let's see if I can. No, that's fine. Okay, I'll make do. So this is the same thing as the fifth root of 32 to the fourth. But if you want to pop into your calculator 32 caret to the 4/5, by all means, that's totally fine.
It's
I feel like
6.
I should. Yeah, go ahead. What is it?
16.
What is 16? Awesome. Yeah, perfect. Because here, the fifth root of 32 is 2. Because 2 to the 5th is 2, 4, 6. I'm counting by twos. Hello. I would prefer, sorry, back to the chat. I'd prefer if people are in class right now and not watch the recording later. Okay. Since this is technically class time. So 2, 4, 8, 16, 32. So the fifth root of 32 is 2. So the fifth root of 32 is 2. And then 2 to the fourth power is then 2, 4, 8, 16.
Wait, I have a question.
Yeah.
So why do you put it to the power of 4/5 and not 5/4?
Say the last part again.
So you know how you put x 5/4 and you did parentheses and you put 4/5? Why?
Oh, so we want to use the reciprocal of this power so that when we have a power to a power, we multiply. So we do the reciprocal specifically so that when we multiply the two reciprocals together, we get this form of 1.
Okay, thank you.
Yeah, of course. Okay. So B, I want y'all to try B on your own. I'm going to give y'all a minute and I'm going to run and get the calculator. I'll be right back. Okay, I'm back. So how did we do? What do we want to raise both sides to?
2/3.
Amazing. 2/3. Perfect. So what are we left with on the left-hand side?
X minus 5.
X plus 5.
X plus 5.
Yeah.
Good.
Nice.
Yes, perfect. Yes. And then over here we have 8 to the 2/3. So let's see. 8 caret. Can y'all see this? I can grab my other calculator with the brighter screen. So 8 to the 2/3 is 4. That's because the cube root of 8 is 2 and 2 squared is 4.
Whenever you raise that power by the reciprocal, does that automatically
Yeah.
cancel it out? So the only thing left over is the stuff that's in the parentheses?
For the left-hand side.
Yeah.
Yes, exactly. Perfect. Can y'all see this? Yes, no, is that worse?
For me, it looks worse.
Okay.
Yeah, I think the other one was better.
Okay. Oop, that's worse. Worse. Okay. Okay, I'll do the other one then.
Yeah, it's way too bright, so we can't see.
Got it. Oh, here, I have another light I can turn on. Oops, let me autofocus. Much better. All right, now let's see. Oh, how's that? 8 caret.
Looks so much better.
Okay, yay!
Yes.
Figured it out. Perfect. Okay, yay! Good, good, good. Also make sure that when you're carroting, especially if you're using this kind of calculator, you have 8 caret and you put in parentheses everything that you want in the parentheses, right? Or everything you want in the power exponent. Okay. Because notice that if I just have 8 caret to the 2 divided by 3, that gives me 21.3 repeating. Because now the calculator is reading 8 squared, which is 64, divided by 3. Does that make sense to everyone? Hopefully. Because that is something that you can shoot yourself in the foot with on a test, and I don't want you to do that. Okay, so we have that x plus 5 is equal to 4 because the cube root of 8 is 2 and 2 squared is 4. Now, what's the last thing we need to do?
Isolate the variable.
Yeah,
Subtract
by
the
doing
point.
what? Perfect. Yeah, so that's just -1 and we're done. Ta-da! How are we doing? We okay? Take your silence as a yes. Okay, good. Very, very good. Okay, so next we've got solving rational equations resulting in quadratic. Oh, can I explain where the 4 came from again? Yes. So the 4 came from, let me share. This 4 came from just simplifying 8 to the 2/3. Long story short. Does that make sense, Elijah? So 8 to the 2/3. Because this is the same thing as the cube root of 8 squared. But the cube root of 8 is 2. So that's just 2 squared, which is 4. Perfect. Good. Okay. So moving right along to rationals with quadratics, we looked at an example of this already when we looked at linear and rational equations, but doesn't hurt to look again. So notice this is a rational equation because we have variables in the denominator. Also notice that if we distribute aka FOIL, x minus 1, x plus 1, we get x squared minus 1. Okay. So while it looks like we have 3 different denominators, we actually do not. Okay, we actually do not. We only have 2 different denominators. So we want to start by clearing the fractions. But again, I'm going to write it emphasizing that this denominator is actually or does factor into these two, right? Because this is the difference of squares. So this is negative 4x over x minus 1 plus 4 over x plus 1 equals negative 8 over x plus 1 times x minus 1. Again, because this is just the difference of squares for these two terms. So now our least common denominator are these two terms, x minus 1, x plus 1. So we're going to multiply both sides by those two factors. Okay, and then technically over 1, if you will. So this gets distributed. All right, I'm going to write the next step. You do not have to, okay? Just so that everything is as clear as it possibly can be. So I have negative 4x times x plus 1 times x minus 1 over x minus 1 plus 4 times x plus 1 times x minus 1 all over x plus 1 equaling negative 8 times x plus 1 x minus 1 over x plus 1 x minus 1. How are we doing so far? What questions do we have, if any? We have done something similar to this in class before, yes. But it can be quite challenging, so it doesn't hurt to do it again. No questions? I'm doing that good of a job? Go me. All right, so what's happening in this first term? Any cancellation? Anything in the numerator and denominator going away?
X minus 1.
Perfect. How about the second term?
X plus 1.
Perfect. And the last?
X plus 1 and x minus 1.
Amazing. Perfect. So our leftovers, so to speak, that's x minus 4 times x plus 1 plus 4 times x minus 1 equals negative 8. So now what do we have to do with this negative 4x and this 4? There's the D.
I'm gonna distribute.
This, perfect. Yeah, distribute. Yay. So this is where the quadratic situation comes into play. So I have negative 4x squared minus 4x, and then plus 4x minus 4 equals negative 8.
And the negative 4 and the positive and the negative 4x and the positive 4x would cancel out, correct?
Oh, I'm glad you pointed that out. So actually, yes, these two right here. Yes, they do. Perfect. Excellent. So we are now left with negative 4x squared minus 4 equals negative 8. But now this is the quadratic. And what do we love quadratics that equal to?
0.
So I have negative 4x squared. Actually, I like my square terms to be positive, so I'm going to kick it over. I'm going to kick everything over to the right-hand side just to make our lives easier. And we're allowed to do that. So let's do that. So 0 equals 4x squared minus 4, right? Because I'm adding the 4x squared to the right, and I'm adding this 4 to the right. So negative 8 plus 4 is negative 4. Do we all agree?
Yes.
We all on
But
board?
like, sorry, my
okay.
friend's right next to me. She has her mic on. If you add that 8 to the other side instead of moving it to the other side, wouldn't it be positive 4?
Yes, you'd have, if I moved everything to the left, it'd be negative 4x squared plus 8. Very good.
Okay.
Yeah. All right, so now we want to factor. So 4x squared minus 4, what do those two terms have in common?
4.
Amazing. Yeah. So that gives us a 0 equals 4 times x squared minus 1. And what is x squared minus? Oh, go ahead.
Sorry, could you remind me again where that negative 8 went? I looked away for a second.
Sure. We just added the 4. So we moved this -4 plus 4 to the right.
Okay, perfect. Thank you.
Of course. So we have 4 times, what is x squared minus 1 factor into? Remember, it's the difference of squares. So it is x, help me out, y'all.
+1 and -1.
Amazing. Perfect. So 0 equals, now it's only 2 terms. Just 2 terms. Because this 4 right here does not have an x attached to it. It is completely a coefficient, okay? Since there's no x attached to this 4, essentially we ignore it. Because if we divide it over, what's 0 divided by 4?
0.
0.
Amazing. Good. Yes, awesome, y'all. So we only have 2 solutions. It's the solutions that have an x in it. So from here, we get that x equals -1, and from the other, we get that x equals +1.
And you can still do the thing that you just put minus and plus and like 1, right? Or do you have to do it separately?
You can do it the same way.
Yep.
But here's the kicker, right? What did we start with? Y'all are going to be annoyed, but this is why the example is here. What is in our denominators?
X
minus
minus
1 and
1, x plus 1.
so what are the 2 numbers that are not allowed to be our answers? What would make me 0 here?
1.
What?
1.
1. Yep. And what would
And
make me
then
0 here?
-1.
-1.
-1.
Yeah. So if I have -1 and 1 as our answers, but those are the 2 numbers that can't be our answers, what is the actual answer? Or lack of answer? Wink, wink.
No solution?
Exactly. Y'all might be annoyed, like, oh my gosh, I did all of that to figure out there's no solution. Yes, you did. Okay, sometimes that's just the way it works out.
So basically x can't equal what the denominator is equal to set to 0.
Yes.
Okay.
Yes. Awesome. Okay, so from the chat, someone said, how do we get a cube root in the TI 8384? If you go into math, the 4 is the cube root. 5 is the whatever root you want it to be. That makes sense. Yes. Perfect. Okay. So essentially, what did you do with the 4? Oh, so back here. So from the chat, just asking again, what happens to this 4? Because there's no x attached to it, it's a coefficient, we ignore it. The only solutions that we get are numbers or are terms that are fused with an x or are a term with an x. So for example, going back, this was 3 solutions because it was a 5 with an x squared specifically. So we got 3, 1, 2, 3. So x, here, x, here, no x. So we don't really consider the 4 because it's just a coefficient. It's just hanging out in front. If it was 4x, then we would get 0. Does that make sense?
Where did the
Yeah.
-4 go?
Let's go. Oh, so this -4?
Yeah.
It became the 1, the -1, when we factored out the 4. So basically, we're taking this term dividing by 4, we take this term divided by 4, and what's 4 divided by 4? 1.
Okay, thank you.
Sorry, I'm checking the chat. Yes, so whenever the final answer is the same as the denominator, it is a no solution. Yes, exactly. So basically from the whatever makes the denominator 0, what that number is, we can't take it. So in this case, we had 1 and -1. That would make our denominator 0, so we cannot take it. Very good. Oh, I love when light bulbs are happening. Amazing. Okay, so we have time probably for just these two, and then we'll finish up with absolute values on Friday. Hopefully in person if my family can get it together. So here we have the next component, which is solving equations with one square root. So going back to what, like, I don't know, the first day of lecture, we're solving for x in this case. So how do we know when we are done solving? Remind me.
And x is on one side when it's just blank equals x.
Exactly. So this is not what we have. We do have an x by itself equaling, but it's not equal to just some number. It's equal to a square root with another x, which is no good, right? So in this case, what we need to do is get rid of the square root so that we can at least get the two x's to become a single x somehow. So with that in mind, kind of working backwards, the first step in this game is to get rid of that square root. And what do we know? Everyone gets rid of the square root. What do we do to it? We
Square it.
we square it. So we're going to square both sides. So on the left, we are squaring it specifically so that the square and the square root cancel out. So we have just 15 minus 2x now equals x squared.
Wait,
Now
I
this
have
is
a question.
yes, go ahead.
So sorry for the last question, actually, like when it said x squared minus one and then the four was next to it, and like you said that like x couldn't be -1 or +1, like what happened to the four?
Oh, so the 4 is just a coefficient. So if I
Mhm.
want to do another, so I have 0 equals 4 times x plus 1, x minus 1, I can divide by 4, so 0 equals x
Oh, we
plus
just
1,
divided.
x
Okay.
minus, yep,
Okay, thank you. That's all.
you're very welcome. Okay, so here, this is a quadratic. What do we love? Quadratic. Is that equal to 0. So I'm going to move everything to the right again because I like my x squared term to be positive. So 0 equals x squared plus 2x minus, right, minus 15. Okay, so now we just need to factor x and x. What two numbers multiply to 15 but add to 2?
5 and 3.
Perfect. 5 and 3. But we want plus 5 and minus 3, right? So that I have plus 5 minus 3 to give us the positive 2, and the plus 5 times -3 to give us -15. So x equals what two numbers?
-5 plus 3.
Amazing. Almost done. Here's the kicker, right? Because there's always a kicker in math. Is that we introduced this square, right? We introduced the square. Technically speaking, we had an x to the first and an x to the first. So I'll say 80% of the time, maybe 90% of the time, one of these solutions is not acceptable. Okay. So whenever you have a square type question, you always need to go back and check. Okay. You always need to go back and check. How you check is you just toss the number in and see what happens. So let's say we start with x equaling -5. Well, square root of 15 minus 2 times 5 is equal to -5. Well, already I'm feeling uneasy because should a square root ever equal a negative number? No. But y'all humor me. What's 2 times 5?
10.
And 10. What's 15 minus 10?
5.
5.
Perfect. So last time we checked, does the square root 5 equal -5? No. So -5 is not looking like a winner. It's not a winner. So let's check 3. What if x equals 3? Well, this says the square root of 15 minus 2 times 3. Let's find out. Does it equal 3? So what is 2 times 3? Y'all help.
6.
6. What's 15 minus 6?
9.
9.
9. And what's the square root of 9?
3.
3.
3. So does 3 equal 3?
Yes.
Yes, yay. So here for this example 5a, the only answer is 3. So question, why is the 5 positive when checking? Is it not negative? Are you referring to this 5? If it's this 5, it's because 15 minus 10 is positive 5. Oh, you mean this negative 5. Oh, yeah, thank you. Thank you. That's because I'm being crazy. So that is positive. Good. So that is 15 plus 10. Thank you. To give me a square root of 25. But even then, in that case, that says a square root of 25 is 5. But even with that being said, thank you for fixing my mistake. First off, thank you very much from the chat. 5 is not equal to negative 5. So still negative 5, no dice. But thanks for fixing my mistake. Perfect. And then we will start with this one on Friday. Again, hopefully in class. Where did I get the 0? Oh, we started by squaring both sides, and then I kicked everything to the right-hand side from the chat. Says, where did we get this equation from? I just moved everything to the right.
Somebody asked if the answer of example 5 wouldn't be plus or minus 5 after you square root 25.
Oh, not plus or minus because the root was already there.
Okay.
If we introduce a square root, we have the plus or minus, but not if we do. Good. Anything else? Otherwise, we're finished for today. It's 9:48. We'll pick back up on Friday.
Wait, quick question. Are you gonna post like the official notes like today or?
No, since today is weird and it was a really last minute of what is happening, I'll post the Zoom meeting for today. But no, so I only posted completed notes when there were people still adding into the class, but I'm no longer going to post completed notes.
Yeah, that's what I was asking because today was the last day to drop the class, right? Without getting anything.
Right, to drop, but not to add. So the last day to
Yeah.
add was last Wednesday. Yeah.
Oh, okay.
So yeah, I'm not gonna post the completed notes anymore. So if you need completed notes, you will need to either get it from a classmate or email and get them from myself, because now I want to keep track of like, is someone habitually asking me for notes type of thing.
Ma'am, I have a question.
Uh-huh.
So like when 25 is about to be like the square root over 25, don't you have to like
here.
square it on the other side too?
Oh, with the checking method?
Yeah, like the second
Oh
to
no,
last step is what I mean.
oh no, because we're just popping it into the original equation to check our negative 5. So here we're just basically popping in the negative 5. So negative 2 times negative 5 is positive 10.
Oh.
Add these together, that's the positive 25. We take the square root because the original question said square root of.
Oh, okay. All right. Thank you.
Good.
That makes sense.
You're welcome. Faith, yes. Every time we have this type of question, you need to go back and check both answers. See, Elijah, the plus 5 minus 3 came from factoring this trinomial. I will post these video notes. Okay. All right, so it's 9:50. We need to cut class. I can hear my child crying, so I also need to cut it short. I know I'm behind on emails, y'all. I'm trying to catch up. I promise. Y'all have an amazing day, and yeah, we'll see what happens for Friday. Hopefully in person. Bye.
Bye. Happy day.
Thank you.
Have a good day.
Thank you so much.
Bye.
Bye.
Have a
good day.
Hope your kids get better.
Thank y'all.
Bye.
Thank y'all. Bye.
Have a blessed day, ma'am.
Thank